So our project was to evaluate the effectiveness of floodplain reconnection sites along the Lamoille Valley Rail Trail. We're hoping that this approach can be somewhat of a blueprint for future rail and river projects. And I want to acknowledge my co-investigators on this project and our VTrans project champion, Jeff Ramsey, and our A&R project champion, Stacy Pomeroy. So we know that floodplains perform many functions of value to society, including storage of floodwaters to reduce downstream impacts, and reduce downstream delivery of sediment and nutrients. And when railroads were constructed along Vermont's rivers in the mid to late 1800s, they tended to isolate or cut off large chunks of the floodplain, which has led to decreased flood and sediment storage and increased downstream flood stages in many locations. So we set about to look at the many rail trails that VTrans has control over across the state, and we proposed a pilot project specifically in the area of the Lamoille and Missisquoi river basins, focusing on the Lamoille Valley Rail Trail. And we decided to develop some tools at a variety of scales that could help VTrans and other stakeholders identify and prioritize these candidate reconnection sites along rail trails. So at a watershed scale, we developed a screening protocol with help of Steffi Drago, a master's student in the Rubenstein School. And this is a simple additive scoring or ranking of river reaches. We tested it out in the Black Creek and also in the Lamoille River as a way to identify discrete segments of the river that would be high priority candidates for another closer look through field vetting. When we applied the screening protocol retrospectively to some projects that had been completed back in 2006 through 2008, we found that our screening protocol predicted those projects as being a high priority. And at another scale, we looked at a demonstration reach specifically near East Fairfield using a two-dimensional HEC-RAS model to evaluate various floodplain reconnection scenarios, ranging from all the way lowering to the old historic floodplain to cross culverts and bridges. We have some interesting results from that, and I invite you to read through the report for that. But I just wanted to share some of the screenshots from that. And I think I'm going to be running out of time, so I'll pause there and ask for questions.
All right, perfect. So I'm going to hold questions to the end of when all the presentations are given. That would allow us a lot of more time to have a rather good discussion from a broader audience. So with that said, we can move on to quantifying nutrient reductions achieved by erosion remediation projects on Vermont's roads by Beverley, Wemple, and Emma Estabrook from UVM.
Okay, so Emma and I are going to switch off on this, and Emma is the lead author of the poster that's on the symposium website. Briefly, our project has three broad objectives. We are building off of work that I've conducted in the past on sources of sediment and phosphorus from our road network. And here we are particularly interested in what's happening at concentrated road outfalls, so culverts that are discharging onto hill slopes. And our project aims to understand the rates of sediment and phosphorus production on those sites, assess how effective intervention measures, so erosion control work, might be in reducing that sediment and phosphorus coming from those outfalls, and also develop a framework for phosphorus crediting under the Lake Champlain TMDL for VTrans. And there are three pieces of this work that we are doing. We are conducting these very intensive terrestrial LiDAR surveys, which Emma is going to talk about. And we are also, those surveys are designed to capture both changes in gullies and also, once erosion control work has been installed at some of those, to track those over time. And then to get a broader view of gully distribution, we're also working with historical airborne LiDAR, going back over time to see if we can detect gullies in the past and how they're changing. And also going out in the field where past road erosion control projects have been installed and looking to see how effective those are. So I'm going to turn it over to Emma now, and she's going to talk about her work on that first piece of the effort.
Emma, you have approximately 1 minute.
Okay, thank you. So to quantify these erosion rates, we're using a terrestrial LiDAR scanner, which is in the photograph to the right of the screen. And this technology has the capability to collect 3D elevation data points through an active sensor. And from there, we can then generate a 3D model to estimate the volume change. And then we're also collecting soil samples at all of our sites as well, to get an idea of how much phosphorus is potentially being mobilized during these erosional events. So the resulting data product from our LiDAR scans is a digital elevation model, which is basically a representation of the bare earth. And from this data set, we can then measure the volume and other characteristics of the gully formation, like the cross section you can see on the right of the screen. And although we're still surveying our sites, we're about halfway through the project, we do have some preliminary numbers we can share. For the most part, we are seeing all of our sites have eroded since fall 2019. And some specific numbers, so for site 31, we've seen that it's eroded about 8 cubic meters since last fall. Site 10 has eroded about 10 cubic meters since last fall, and site 3 has eroded about 16 cubic meters since last fall. So we're already seeing that these sites can potentially erode a decent amount of sediment over a pretty short amount of time. And I encourage you to check out our fact sheet and poster on the VTrans website. Thank you.
Thank you for that presentation. We're going to turn it over to Nationwide Monarch Butterfly Candidate Conservation Agreement, CCAA for the acronym, for energy and transportation lands by Glenn Gingras from VTrans.
Okay, the Nationwide Candidate Conservation Agreement with assurances for the Monarch Butterfly on energy and transportation land represents unique collaboration between the University of Illinois at Chicago and the U.S. Fish and Wildlife Service, and more than 30 interested entities from the energy and transportation sectors. This voluntary agreement embodies the landscape scale conservation vision that has been recognized as being needed for monarch butterflies. With this agreement, partners may enroll their energy and transportation lands, which are called enrolled lands, that are included within the covered area. Within the enrolled lands, partners then commit to adopting targeted amount of conservation measures based on the extensive lands enrolled, which are the adopted acres. Signatories to this agreement receive assurances that additional conservation measures behind those in the agreement will not be required for monarch butterflies, and additional restrictions or limitations will not be imposed upon them if the species was to become listed as a threatened species, threatened or endangered species in the future. The total acreage for enrollment for VTrans was 42,534 acres, consisting of limited access right-of-ways, U.S. and state right-of-ways, selected VTrans land holdings, and miscellaneous lands, including airports and facilities depots. The conservation practices VTrans have included on the adopted acres are mostly practices included in the best management practices already in use. These include idle lands. We have a current rotational mowing practices allow for areas that are not mowed and kept open to pollinators. Brush clearing, which creates additional open lands. GIS mapping of milkweed and wildflower patches, using integrated vegetation management practices, and public outreach.
You have about 45 seconds.
Okay. Currently, we are in the process of completing Tier 2 biological effectiveness monitoring at 30 randomly selected sites throughout the adopted acreage. The monitoring assess the quality of pollinator habitat. Tier 2 monitoring includes estimating flower nectar plant cover, determining abundance of milkweed, counting blooming nectar plants, observing additional habitat features, exploring threats and opportunities. This monitoring will be completed in the early fall, and an annual report will be required to be completed by March of 2021.
All right, so I guess we can open up the floor to any questions that anyone on the line has. We have about 15 minutes, so don't be shy on asking any questions. As being a hydraulic engineer, I kind of want to ask Kristen one question. How long did it take you to run those models?
Yeah, thank you. So I neglected to mention that my PhD student, Lindsay Worley, was largely responsible for this model, and I wish that she could have been here today. We had various simulations in that model, and each model run now takes about 2.5 hours, and of course that's an iterative process. When we first started out, it was taking many more hours than that to run one simulation, but she diligently worked to streamline things, and now we're down to about 2.5 hours per run, and that's on a typical desktop with today's memory and RAM. So we do have the option to run it on the Vermont Advanced Computing Core as well, which we're looking toward for her continuing research using this model. And we expect the run times will be a little bit shorter, but more importantly, we can run various scenarios in parallel by using that Vermont Advanced Computing Core. So we're looking forward to that possibility.
I'll ask a question regarding the nutrient reduction presentation. So did you guys correlate any, so you guys have a LiDAR scanner, and I take it that you go to a site multiple times throughout the year, maybe before winter comes, after winter comes, and you maybe after a good rainfall too. Do you guys try to correlate erosion rates with respect to the slope and type of the soil? Or I'm just kind of curious on that one.
Yeah, that's a really great question. And that will probably be a later step in our work when we go into more of the analysis. But we're definitely interested to see if hill slope affects like how fast these gullies are eroding, if soil type affects that, and also if the specific drainage area, so like how much water is pouring into that site, if that might influence how quickly these erode. But yeah, those are all really great variables, and I'm also curious kind of how it'll all end up. Do you have anything to add, Beverley?
Well, maybe just that in addition to this very intensive field work that Emma's doing, she's developing this desktop protocol that I mentioned in my introductory slides. And we only have about 13 sites that she's surveying that intensively, but we hope to have several hundred that we can detect from the airborne LiDAR, and that'll give us more statistical power to look at possible explanatory factors, topography, soil type, those kinds of things. Kristen, we're hoping to ask you about parent material controls.
Yeah, Emma already beat you to that. She actually asked me this morning. So one question I have for you guys is, did the Halloween storm, do you think, lead to a lot of the erosion that you've detected so far?
Yeah, so we did a couple of intensive surveys. So we didn't do like a full check on all of our sites after the Halloween storm, but we did look at a pair in Colchester and Winooski. And weirdly, one of the sites actually decreased in volume after the Halloween storm. So I'm wondering if that site, it had some really intense undercutting in part of it. So I'm wondering if maybe like there was some deposition and it fell down or something. But I was really surprised by that result, that one of our sites actually decreased in volume.
Right.
But that's the only case where it's decreased. In all other cases, our volume is increasing after storm events.
So how important is the regional collaboration with the Monarch CCAA?
I believe it's super important for the conservation of the species. It's been in very high decline over the last few years. I mean, it's being proposed for listing on the threatened and endangered species list. So it's in peril right now, and it's mostly around habitat. So if people can do it regionalized, improve habitat for the species, I think it would make improvements overall to the overall population of the monarch.
Got it. So a question just came in the chat feed, and the question is regarding the erosion presentation. Is there a density measurement obtainable from drones that could inform you on deposition after erosion? And that's from K Hopper.
Yeah, that's a good question. And we actually did consider using drones at the early part of this project. The main reason why we went with the LiDAR instead of drones is because of the way the data is collected. With the drones that we have access to, it uses a process called photogrammetry. So it just takes photos to develop the digital elevation model. And one of the limitations of that is it doesn't work super well in dense tree canopy area. And that's where actually a lot of our sites are, is in kind of a wooded area. So we might get some good pictures of the trees, but we're really interested in the ground. So we can't get super great photos there unless this was like a longer project where we could systematically like choose to only fly during leaf off conditions. But that's also kind of hard in Vermont because, you know, the leaves fall and then there's snow on the ground.
Thank you. James Murdoch raised his hand, so I'll let him speak on his behalf.
Great. Thank you very much. This is a quick question for Glenn. Glenn, hi, this is Jed from UVM. Sorry, I missed the first maybe 30 seconds of your talk. I was caught in the other meeting. But does your post or your monitoring efforts of these areas for butterflies include actual counts of or some measure of like how many butterflies there are?
It's actually it's called Tier 2 monitoring, and there's a whole protocol. It's very simple sort of monitoring where you go and you estimate percentages of nectaring plants on a plot, and the plots are all 10 by 150, and you do meander surveys through them, and you actually count stems of milkweed. You identify, well, you don't identify, but you know if there's other bees, wasps, other pollinators, monarchs, anything of that sort that you observed during your monitoring. So we did find a lot of other types of butterflies and moths, and we actually did record several monarchs as well.
And do those data become archived in
Yeah, it all goes into, it's all collected in ArcGIS online in Survey 123, and it's all uploaded into the national database for this effort.
Okay, so K Hopper also asked, is there for the erosion presentation, is there a method to measure the density of compactness of the soil after rain events that would indicate it was a deposition event less or greater than or equal to less impact?
There is a way to measure soil compaction. We're not actually doing that. The sites where we're doing these very intensive surveys are at the outlets of culverts, and water passes through the culvert and erodes the hill slope. But in some cases, as in the site that Emma was mentioning, we may have either sediment being transported down a ditch line and discharged into the gully, or we may have gullies that are so deeply in size that their sidewalls are falling in. And it sounds like that's what Emma suspects at that one site. So we think that the issue really that we're documenting change has to do with erosion or transport of sediment by water that's flowing through.
All right, so what I was curious about is I was hoping for a possibility of something from like aerial photography that could measure density. I know that NASA has stuff that actually looks at I think they're able to pick up like water density. And what I was wondering is, instead of doing the soil thing locally, the soil test locally, I was wondering if there's a way to view it either with a drone or with a local LiDAR, where you could actually probe the depth and get the compactness with the LiDAR tools or some other tool, but where you don't actually have to get the soil compactness locally, as a way to actually help looking for bridge scour, where you go and you look at it after a significant event. It looks like there's dirt there, but if you actually looked at the density of the dirt, you would realize it was actually an erosion deposition event, and it's actually a pretty high risk location. So that's what I was asking about.
Yeah, okay. Haven't thought about that. I guess what your question is making me think about is the fact that we are sort of searching around for a soils or parent material variable that might help us explain variability across space in the occurrence of gullies or the size of them. I'm not sure about a product that could be collected by drone or remote sensing that would do a good job of characterizing something like, I'm thinking you're referring to soil bulk density. But we do definitely have in mind this idea that the extent to which concentrated water at outfalls erodes hill slopes will likely be due not only to the topographic conditions, how steep the slope is, but also soil strength types of parameters. So we're thinking about and gonna quiz Kristen soon on the best variables she can think of to use for that.
Okay. I have, thank you, Keg. I have one question for Kristen. Was there anything that surprised you during this research? Was there any like ahas or oh no's or we can't do anything? Sometimes you go through this entire process and sometimes it's inconclusive or you just don't have a good answer because it's just too developed. The base is too developed to fix.
Right. Yeah, I would say that what surprised us on this project was that the site was chosen by our technical advisory committee because of, and I'm speaking of the site that we modeled using the two-dimensional HEC-RAS model. That particular site was chosen because it was proximal to a wetland restoration project that was being considered by the landowner. And it had been identified as a possible rail bed lowering project back in 2006, 2008. But what we realized in hindsight is it was not probably a very ideal site for being a demonstration site because it was located at the confluence of the Elm Brook tributary and the Black Creek, and so it became very difficult to parse the impacts of various reconnection alternatives on flood parameters because we had that convergence of stormwater happening at that confluence. And also there was, we found a lot of very cool historical information for this site that indicated there was already a degree of cross connection between the Black Creek floodplain and the Elmbrook floodplain occurring through the base materials of the railroad bed itself, just because they had blasted a path through bedrock to create the railroad and used that blast rock as the base material for the section of railroad that we were looking at modifying. And that blast rock allowed for seepage, groundwater seepage, and so there was this pre-existing degree of connection between the two floodplains that was very difficult for us to model. So all in all, it was a very complicated site to model, but we were pleased with the discussion that has been generated around the topic by this demonstration project, and our model still can be very useful to the landowners who are considering that wetland restoration project, and they should be able to use our model to simulate various restoration techniques. And VTrans, we're hoping, can use this kind of an approach as well to think about attenuating sediment and phosphorus in floodplains for their phosphorus control plan. So that's a long answer to a short question.
We're going to view the leveraging high resolution LiDAR, and stream geomorphic assessment data sets to expand regional hydraulic geometry curves for Vermont by Kristen Underwood from UVM.
So this is a project that actually has been sponsored by the TIDC, the Transportation Infrastructure Durability Center, headquartered at the University of Maine, and it's a consortium of universities doing research on transportation. Our project champion locally here in Vermont through VTrans is Nick Wark. Excuse me. And regional hydraulic geometry curves are a set of equations that are used to predict a stable bankfull channel width and depth in rivers based simply on their drainage area. We use regional curves to size bridge and culvert crossing structures so that their width and their vertical clearance is more compatible with river surroundings to allow for a safe passage of fish and other aquatic organisms. We also use regional curves in order to, during post-flood recovery work, in order to properly size that recovery, the infrastructure that we're repairing, to give enough room for the river so that over the long term we have more sustainable infrastructure. And when the curves, the regional curves for Vermont were first produced back in 2001 and 2006 by Shane Jakewith and Mike Klein at A&R. They were one of the Vermont was one of the earliest states in New England to develop these curves as part of their earlier efforts to manage rivers. They're statewide curves based on 21 observation points, and practitioners in the field have noticed over the years that these curves do not well predict bankfull width or channel dimensions in all settings, particularly the low gradient coastal settings along Lake Champlain, for example, or conversely the very steep headwater settings that are in confined or semi-confined settings. Since these curves were developed, we have gathered stream geomorphic data across 2,300 miles in the rivers of Vermont, and we also have acquired high-resolution LiDAR data available to us. Is that the 1 minute mark?
30 seconds. I just didn't want to, just keep going. I'll give you time at the end. Sorry about that.
So these are our research objectives in a nutshell. We want to expand these curves, include a greater number of observation points, leveraging that stream geomorphic assessment data and the LiDAR data that's now available. Perhaps employ additional predictor variables so that we can reduce the uncertainty with these predictions and improve their overall utility. So this project is at a midpoint. We had some delays due to the COVID pandemic, and at this point we've identified 10 new sites under some fairly strict guidelines. Some of these are in bordering areas of surrounding states, in fact, and our next steps this fall for a final report due in January of this coming year are to continue with some statistical techniques to relate new predictor variables to the response variables, the stream geomorphic metrics. Hopefully we'll have a new and updated set of curves for folks to use on or about January of 2021.
Thank you so much, Kristen.
Yeah.
So we'll be moving on to surveying and cataloging the state's cultural resources using GIS, recent progress and next steps by Judith Ehrlich from VTrans and Brad Ketterling from VHB. And if I mispronounce your names, I apologize in advance.
All right, well, good afternoon, everyone. I'm Judith Williams Ehrlich. I'm the VTrans Historic Preservation Officer. I work in the environmental section reviewing projects for their potential effects to above ground historic resources per the requirements of state and federal regulations. As part of our research, we review existing records of previous projects, state surveys, National Register listings, and other things. The main repository of this kind of information is the Vermont Division for Historic Preservation's Online Resource Center, or the ORC, which contains PDFs of thousands of scanned records. Documents in the ORC can be massive, even over 6,000 pages, making them time-consuming to use. Some are just old, say from the 1970s, which means that the information may no longer be accurate. Surveyed properties may not even have addresses. There are maps that illustrate locations, but these have been scanned and reduced, so they can be difficult to read. Despite these flaws, reviewing the ORC remains a requirement of our reviews. So we determined we needed a location-based digitized system for historic resources in Vermont, something like the ANR Atlas. We were given the go-ahead to seek funding to pursue this idea, and we were approved for FHWA STIC and PDWP funds. VHB agreed to partner with us, and the first phase of the project was for VHB to build a survey app to evaluate properties and establish a baseline map. Once VHB started working on the survey tool, we realized it would be helpful to test it on an actual project, so we combined the creation of the survey tool with a mitigation requirement for the Middlebury Tunnel project. Because the Middlebury project adversely affected 2 historic bridges in the town center, the mitigation measure required the creation of a new National Register nomination for the Middlebury Historic District.
You have 1 minute left.
Okay. VHB created a survey tool using Survey 123, and they started gathering information on buildings in Middlebury. The information gathered is georeferenced and maintained on an overall map of the project area. This is a big change in how historic resources of Vermont are reviewed and managed, and allows for more interactive research. After creating the survey tool, the next phase of the project involves exploring how to georeference all that existing data in the ORC and add it to this new overall map of Vermont. A web-based historic resources data system will streamline VTrans project reviews. Our long-term goal, however, is that the system will be available for public use. This way, other government agencies, municipalities, nonprofits, educators, and others will be able to access the information as well. So there's an extensive amount of information available concerning historic resources in Vermont, and making it more accessible will help improve the protection of these important architectural resources, which are so integral to our lives, our shared history, and our heritage tourism economy. That's it for my presentation.
Thank you so much. We will move on to ranking transportation structures in Vermont by their potential to facilitate wildlife passage, a connectivity modeling approach by Caitlin Drasher and James Murdoch from UVM.
Hi, everyone. My name is Caitlin Drasher. I'm a graduate student at the University of Vermont, and I'm working with this great team listed here. And today I'll be introducing how we are ranking these transportation structures by their potential to facilitate wildlife passage and the connectivity modeling that we're using to do this. So we are developing a ranking system to figure out which transportation structures are most important for wildlife movement. Roads obviously fragment the landscape and can impede wildlife movement, but transportation structures are one way that we can improve landscape connectivity for wildlife. By ranking existing structures, we can figure out which ones are most important for connectivity and can target those for improvements to make them more wildlife friendly. But before we can rank our structures, we first need to figure out where the wildlife are moving so we can identify areas of the road network that are important for animals to get across. And we are modeling the movement of 8 different species in Vermont using a circuit theory approach, which views wildlife movement like the flow of electricity through a circuit. This circuit, or the landscape, is made up of resistances, which changes how that electricity, or the wildlife, flows across the landscape. So in our Vermont landscape, human development would have a higher resistance to movement for most species, whereas large blocks of forest would have low resistance. And again, we're developing maps for multiple species, but the examples you see here and on our project page have been created for using data from American marten, which are listed as endangered in Vermont. This is a very quick breakdown of our process, but we'll be modeling connectivity at 2 spatial scales. First, we perform the analysis at the statewide scale to view wildlife movement for the entire state of Vermont. And on the top part of the slide, you can see that we have 2 inputs. First, we have data on where the wildlife are occurring, which tells us how much electricity we have and where it's coming out of the landscape. And next, we have our landscape resistance data, which tells us how that electricity travels. This results in a connectivity map representing wildlife movement. And the next step is to zoom into the structure scale. Here we perform the same connectivity analysis, but this time we do it with detailed high-resolution LiDAR data around each individual structure. And we can then rank structures based on how much current density surrounds them at both the landscape scale and the structure scale. And so far, we've run the statewide analysis for over 6,000 structures in Vermont for American marten. Some implications of this research. Our analysis helps road and wildlife managers visualize where animals are moving throughout the state and how they move across our roadways. So when transportation structures are scheduled for maintenance, managers can then prioritize funding to those that have a high connectivity ranking to make them more wildlife friendly. This might mean adding shelving, changing the substrate, or changing the size, shape, or type of a culvert. And that's probably all the time I have, but definitely check out our project page if you're curious about the circuit theory approach or interested in issues related to wildlife and roads.
Thank you so much. With that said, are there any questions that anyone has?
I have one for Caitlin. When you're modeling at that statewide scale, are there challenges at the borders of Vermont? Like, how do you? I just envision electricity going off the Canadian border. How do you address those challenges at the border?
Yeah, so we're actually going to have to expand our analysis past the borders of Vermont a little bit. The connectivity modeling tool, that Omniscape program, it uses a moving window. And that moving window size, when it's doing its analysis and traveling across the landscape, it's based on the dispersal distance of a wildlife species. So if we're modeling American marten and their average dispersal is about 20 kilometers, we would need to buffer outside of the state about 20 kilometers. So definitely going to have issues with like Canadian data. I haven't tackled that problem yet, but in terms of like New York and New Hampshire and Massachusetts, we have occupancy data for all of our species in those areas.
Cool.
Yeah.
Thank you.
Thanks.
So there's a question for you again. Can you share the 7 other species that you're studying?
Yeah, let's see if I can remember them off the top of my head. But we've got the really big charismatic species, so moose, deer, and bear, bobcat, coyote, striped skunk, raccoon. I already said bobcat, fox, red fox. I'm missing 2 more, but basically like the larger ranging mammal species that are most likely to cross roads in the state of Vermont. So far, we've only done our preliminary analysis for marten, though.
And then from Kay, I'm assuming this is for Caitlin again. Do you incorporate car with wildlife interactions?
That's a very good question. Unfortunately, a lot of the roadkill data we have in the state isn't collected in any consistent way. It really depends on who was collecting the data, how accurate that point is, where the animal is hit. Sometimes you get just the name of a town and a road, and sometimes you get actual coordinates. So we're not using it to incorporate into these models. We're mainly relying on data on wildlife occupancy and landscape resistance. But we might incorporate roadkill data when we're testing our models to see if what we're seeing with the electricity flow across the roadways is matching what we're seeing in areas where we do have good roadkill data.
Kristen, I have a question for you regarding your project. Have you found that, like, what variables are you including into your new regression equation? So, obviously base area, but what are the other variables? I'm just curious.
Drainage area for sure. We're trying to balance a couple things. We want to develop curves that will predict more accurately and with less variability, but at the same time we want curves that are simple to use and that can be used by a variety of practitioners. We have folks from academics to river scientists to consultants designing new infrastructure that are using these, to road crews. And so we're mindful that we want to develop equations that are fairly simple for ease of use. So we're exploring the idea of maybe 2 sets of equations, ones that are simpler, that don't achieve quite as much a reduction in the uncertainty as others would, and then a more complicated set of equations. And maybe we generate mapping for large rivers based on that more complicated equation. But some of the additional predictor variables that we're thinking of are things like slope or mean basin slope, because we're hearing from practitioners that the current curves are not well suited for steep and very flat. So we may incorporate a slope element. I believe Massachusetts found that to be very helpful. But we have a long laundry list of predictor variables that we've developed, that my student Sienna Roberge developed this past spring. And so now I'm just in the process of running the statistical analyses that will hopefully tell us which of those parameters is most important in predictions.
Okay, perfect. Kay has a follow-up question for you, Kristen, and it kind of segues into something I was thinking of too. Are the curves rated to a risk variable based on the stability of the river? So I was wondering too, like, okay, material type. So a cobbled bed versus a sandy or clay bed may have an impact on the bankful width of a stream or river.
Yeah, true. So not explicitly in that way, but we are exploring stratifying the sites that we have developed by their stream type. So for example, a narrow and deep channel, what those who are familiar with the Roskin system of classification or the ANR stream geomorphic assessment protocols, these are the E stream types. They may have a very different relationship to predictor variables than our gravel bedded steeper channel rivers. And so we're looking at stratifying or separating the curves for those two groups, for example. And I think that would get at Kay's question of risk variability, or in other words, some stream types are going to be more sensitive or more likely to adjust than other stream types. And so stratifying by stream type, we hope, will be helpful. The challenge there is that we just don't have enough observation points probably to do a whole lot of stratification.
So Judith, how do you think the GIS databases you generated can be used by other VTrans employees or even just other consultants statewide?
Well, the information will be, like I said, everything's georeferenced, of course, because it's a geographic information system. So right now, what we have are just paper records. So if we have a question about a type of resource, for example, if we are looking at historic barns, we want to know how many monitor barns are left in the state. We really don't have the capacity to find out that answer. Once we can digitize all the information that's available in the ORC and hopefully do new survey as well, we'll have a much better handle on what the historic resources of the state are like. Information like that will aid towns, municipalities, regional planning commissions when they're planning, putting together project plans. And I think that this is hopefully going to open up some opportunities for educators to put together some learning plans for, to looking at the surroundings, look at the history of your state. And so there's, I think, a whole myriad of opportunities out there that I'm not even aware of, but right now can certainly help other entities with project planning.
Judith, this is Kristen. I may have missed it in your presentation, but how far back will records be scanned or digitized in that system?
So what the scanned records in the ORC represent are all of the Division for Historic Preservation's records starting in the early 1970s.
70s,
so,
okay.
Yeah, so the goal would be to capture all that information.
Okay. Is that a big effort? Is that a big endeavor? Lots of folks scanning, spending their days scanning?
Well, it's all been scanned already.
Oh, I got you.
So the ORC is, I used to work for the Division for Historic Preservation, and we had one large room full with all of our paper records, thousands of feet, linear feet of records. And we took several years and a consultant to do just that, to take all the records, scan them, organize them, put them in files. And that's what we've got right now to work with. So it's a big cumbersome system that we hopefully will georeference. So there's going to be a lot of points out there.
Nice.
So I'm going to ask a general question to everyone. It was kind of similar, so regarding the wildlife, aspect of everything, you have to set up a lot of trail cameras or use available cameras on bridges and stuff. What are the next steps? Do you have any next steps in the sense of you have to go to Canada. So are you going to have to get a passport or an extended license and go up that way and just try to track some more animals?
Well, thankfully, the camera data that we do have is also going to be used to sort of test our models, and the models that we are building and the ones that are going in to make these cool, flashy connectivity maps, they're relying on data that's already been collected by previous researchers. So it's really just a matter of, cleaning up that data and putting it into this program and letting it run and seeing what happens with it. And then we'll be testing it with the camera data we have at known locations in Vermont. We obviously can't put cameras everywhere. They're very expensive, very time consuming. So when we are testing the models, we'll just be looking to see how well they perform based on where we do have cameras. Like, is it comparing well to the amount of wildlife we see? Similar as with the roadkill data. Does that answer your question?
Yeah, it does. I just was wondering if you had a camera like every, I don't know, 50 square miles or whatever.
Yeah, no, I think there've been cameras have been all over the place and they've moved around to different transportation structures. So I'm not sure the exact number of cameras we've had out, but I think it's around in the 70s, and sometimes multiple cameras at one given structure because you want to get different angles to make sure you're not missing anything. So yeah, but we can't put them on under every structure, unfortunately.
Right. Okay, here's a question from Kay, and this is regarding Judith's presentation. How does a survey discrepancy affect a historic georeference document resolution for geolocation output? I don't know if you can see that in the chat, but I can repeat that if needed.
Let me, I don't, oh, hold on, I have the participants up, not the chat. Yeah, could you repeat it for me?
Yep. I'm also emailing it to you too, just in case.
How does a survey discrepancy affect a historic? Well, I mean, it would be problematic. That is one of our next step, is to figure out how to take that large amount of data and georeference it. Our next steps are going to be to choose several towns in the state and do kind of a dry run and see if it's, by individual pieces of data, or is there a way for us to do this more on a broader scale? So once we look at that, we'll be able to figure out how much we can do some quality control on the data itself and what we're bringing into the system. So that I'm having a hard time answering your question because we just don't know completely yet. It would be problematic, definitely, to have misinformation on a form of, and that informing where we drop our points. But hopefully we will be checking and confirming the locations for everything that we georeference. The goal is to have this as accurate as possible.
Thank you so much. So James Murdoch said, as a quick follow-up to Caitlin's comment, an important next step for our project is to package the results into a terrestrial wildlife passage screening tool that will incorporate other wildlife information / data to help with decision making. So I could see that from sizing bridges, that if we need to put a corridor in and make sure that, moose are going through, we don't want them to be trekking through during like a 2-year storm event or something. So that will be useful for even structural and hydraulic engineers too. So thank you so much. So we have about 4 minutes left. Are there any itching questions out there? Well, Christian, I know you're listening in. I'm going to call you out. You're a recent grad student from UVM. Any questions regarding the regression equations? He's quiet. I don't know if he's just sitting there or not.
Hi, Jeff. Hi, Kristen.
Hi, Christian. How are you?
Pretty good.
Good.
Thanks for the call out, Jeff. I guess I was just kind of curious if you would like, if the plan is to make another stream stats kind of idea with your regressions curve, like a new mapping software for Vermonters to use, like me and Jeff, if that's the idea.
Yeah. We had not anticipated that in this particular project scope, but we do anticipate that these new curves, updated curves, essentially they're predicting what the stable geometry would be for a river. And so we can do that on a broad scale. We can use the new curves to predict and map what the channel width and depth and cross-sectional area should be across the state, and then compare that to what's actually measured in the field through these stream geomorphic assessments and river corridor plans. And we expect this will be part of a layer that underlies the Functioning Floodplain Initiative, which is a kind of a statewide initiative to compile information on how well connected rivers are to their floodplains, and to leverage floodplains for storage of floodwaters and also storage of sediment and phosphorus. So this research product will be a small part of that broader Functioning Floodplains Initiative project.
Okay, thanks.
Yeah.
I knew he had a question. He just was shy to ask it. So, so Kay is asking regarding the wildlife passage. It's more of a, she said, I think often the hydraulic adequate structures are good for wildlife passage. Do you agree?
Yeah, I was just typing a response back, but in earlier phases of the project, based on the camera data that we have, structures that have been retrofitted based on the aquatic organism passage screening tool have had more use by terrestrial species as well, especially the ones that are, have been made wider, or the banks have been changed and made more accessible for terrestrial species. So that seems to be the trend, I think, based on camera data in earlier phases of the project.
Great. Thank you so much. It's 3 o'clock right now, which ends our time slot. If you have any questions, please reach out to each of the presenters using the contact information on the website. And I just want to say thank you again, presenters. You did a great job. Thank you and have a great day.
Thank you, Jeff. Thank you.
Thanks, everyone.
Yeah, thanks, Jeff.